In our next section, we're going to look at PE to CE routing with IS to IS, which is only supported in regular iOS and the current versions that we are using. And as I mentioned, this is a pretty small corner case. You typically would not be running IS between your customer edge and the provider edge, but it is a possibility, and it does cause some potential problems. So we do need to talk about it within the scope of PE to CE routing. Now, what we're going to be doing here is to make a minor change to the topology. I'm going to be adding an additional link that goes between router 1 and router 10, and this is going to be in our VRF-B, and then we're going to be routing to VRF-A, which is on the site between router 3 and router 7. So first we're going to configure the IS to IS routing between the customer and provider from router 10 to 2, from router 10 to router 1. Then we're going to do the redistribution between BGP and ISIS, make sure that the routes get advertised as L3VPN, and then see what the final result is once they get redistributed from BGP back into ISIS. So as it stands now, I have the core of the network pre-built, and we should see that we have reachability from routers 1, 2, and 3 in terms of both the label switch path plus IGP. So if we look at the show MPLS forwarding table, we see that we have labels both for router 2 and for router 3. And then if we look at the show BGP, VPN v4, unicast, all summary, we also have peerings between router 1 and 2, router 1 and 3, and then router 1 is our VPN v4 route reflector. Okay, so next we're going to configure this new link between router 1 and 10. Let's say that this is interface gig1.110. The encapsulation is .1Q110. IP address will be 10.1.10.1. And same thing on the other side. So let's say, or actually before that, this is going to be in the VRF. VRF forwarding will be B, and VRF B needs to be configured like it is on router 2. So let's say show run VRF. We'll grab our VRF B config. And then that's going to go on interface gig 1.110. Okay, VRF forwarding B. Okay, we then also have our IP address. From 10's point of view, this link is going to be in the global table. So on router 10, we have gig 1.110, encapsulation.1Q110. IP address is 10.1.10.10. And if we ping 10.1.10.1, we should get reachability to router 1. Okay, the other segment we have here is 10.2.10.2, which we do have reachability to. Okay, next step, we're going to enable the global ISIS process on router 10. So this is the customer router. It's not going to be participating in the VRF. It's not going to be participating in any of the MPLS. So we'll say that we have router ISIS 100, and our net address we'll say is 11. 0.0.0.0.0.0.0.0.0.0.10. Okay, then at the link levels, so gig 1.110, we have IP router ISIS 100. Same as the link to router 2. So that will be 210. And then same thing on the loopback. Okay, so from router 10's point of view, this is just the global ISIS process. From router 1 and 2's point of view, we're going to have this additional process, router ISIS 100. We're going to specify that it's VRF aware, so the VRF is B. The network entity title, we're in area 11. And then at the link level, gig 1.110, we have IP router ISIS 100. Okay, same thing is going to be true on router 2. So let's say we have router ISIS 100, VRF is B. The network entity title is 11, all zeros and a 2. Then at the link level, we have IP router ISIS 100. Okay, from 10's point of view, if we look at the show ISIS neighbors, we should see that we have adjacencies both with router 2 and with router 1. And notice that with the default behavior of the ISIS process, we're establishing both level 1 and level 2 adjacencies. So we have not set the IS type globally under the process, and we haven't set the circuit type at the link level. Okay, from router 1, if we look at the show IP route VRFB, we should see that we're learning the loopback of router 10, because we have 10, 10, 10, 10. We're learning this through ISIS. Okay, likewise, if we go over to router 2 and we show IP route VRFB, we should be learning the loopback of router 10. Okay, if we ping to this destination, 10, 10, 10, 10, we should get reachability both from router 1 and from router 2. Okay, so next we have the same config on the other site. So from router 3's point of view, we're going to say we have router ISIS 100, network entity title. The VRF is going to be A in this case. And then at the link level, we have IP router ISIS 100. Okay, on 7, same thing. So we have router ISIS 100. We have our network entity title. And then at the link level, we'll say on the loopback, IP router ISIS 100, and as well as the port to router 3. Okay, so from router 3, if we now look at the show ISIS 100 neighbors, we have the level 1 and level 2 adjacency to router 7, and if we show IP route VRFA, we see we have its loopback. Okay, so now we have the basic routing from the PE down to the CE. Next step is that we're going to redistribute the routes into VPN v4 BGP and make sure that our route target import and export policy is going to allow for the PEs to exchange the routes. So even though they're in separate VRF names, like we saw before, the route target ultimately is what controls the VPN membership. So if we look at the show VRFA detail, and we look at the, or show VRFA, no, show VRF detail. Show VRF detail. And look at the same output on router 1. We just need to make sure that we have a matching route target value. So let's say that under VRFB, under address family or VRF definition B, we have a route target import policy, let's say of 123.456, and export as well. Okay, so we're going to do this on routers 1, 2, and 3. VRF definition B, new import export, and then same on router 3. Okay, last step is going to be the redistribution between the BGP process and the ISIS process. So starting on router 1, if we look at the show run section BGP or ISIS, we'll say that under ISIS 100, we're going to redistribute BGP 1 level into level 1 and level 2. And then under router BGP 1, the address family is VRFB. We're going to redistribute VRFB, redistribute ISIS 100. Okay, so same thing on all 3 of these devices. The only difference is that router 3 has the different VRF name. Okay, so what this would look like then is to say that on, okay, so we have our router ISIS 100 process. We're redistributing BGP into level 1 and level 2. Under BGP, we have then our VRF, and we're redistributing ISIS. Okay, so this is the config on router 1 and router 2. And the config on router 3 is the same, except we have a different VRF name. It's VRFA. Okay, final verification is going to be from the customer edge. So let's say from router 7's point of view, when we now look at the show IP route ISIS, we should see here, ideally, that we're going to be receiving those routes about the other site. Okay, so let's see, did the PE routers actually do the redistribution? So from router 1, let's look at the show BGP, VPN v4 unicast for VRFB, and Looks like we didn't do the redistribution. I think what I'm missing here is that I didn't specify the levels, okay, under the BGP redistribution. So kind of similar to in OSPF, if we look at the show run section BGP, when you redistribute ISIS into another protocol, it only takes the level 2 routes by default. If you want to include both levels, you have to add that keyword, level 1, level 2. So here on router 3, we're redistributing BGP into ISIS level 1 and level 2, and we're redistributing ISIS level 1 and level 2 into BGP. Okay, router 1 and router 2 will be the same, but different VRF name. Okay, so let's try this again from router 7 then. We show IP route ISIS. And let's check from 1 and 3 now. Okay, again, we look at the show BGP, VPN v4, unicast for VRF-B. Okay, now we're doing the redistribution. So we have the 10, 10, 10, 10. And let's take a look at this from router 3's point of view. From 3, if we show BGP, VPN v4, unicast for VRF-A, we have the 7 route, but we're not receiving the remote routes. What I would assume the problem is now is that this is something to do with the route target import and export policy. Because router 1, we saw that it did do the redistribution from ISIS into BGP. Likewise, router 3 is doing the same. We have the 777 route that got redistributed into BGP. We already know that they're peering from before. Router 1 is the VPN v4 route reflector. But if router 3 is not receiving these routes, I'm assuming that either router 1 is not tagging them when it's doing the export, or router 3 is not actually importing that target. So again, the way that we can troubleshoot this is if we look at the debug BGP, VPN v4 unicast updates, and then ask for a BGP route refresh inbound. So let's say clear BGP, VPN v4 unicast star in, and we can see that's exactly what the problem is. It says the route is being denied because the extended community is not supported, the extended community being the route target. So we should see 10, 10, 10, 10 being received in. It says the route target is 200, 200. Okay, so let's undebug there and let's look at the show run VRF. Show run VRF. The issue is that I have the route target configured, but I don't have it under the address family. If we have one under the address family, that's going to override the one that's global under the VRF. So what this basically means is that if I have IPv6 enabled for VRF-A, IPv6 would be importing and exporting 1, 2, 3, 4, 5, 6, but address family IPv4 has a more specific import and export policy. So either I need to take this information and move it under IPv4 or delete the ones under IPv4. Either way would be fine. Okay, so let's just remove the ones that are under v4. So don't export 100, don't import 100, and then the same on router 1 and 2. Let's say show run VRF, and they have the same problem. Okay, so let's say that we don't have a specific import-export policy. We have the one that applies to both AFIs. Okay, so next let's look at the show BGP, VPN v4, unicast, VRF-A, or excuse me, VRF-B. And then we should see that these new routes get imported. So let's clear BGP, VPN v4, unicast star out and in. And then show BGP, VPN v4, unicast, VRF-A. Okay, so now we have the routes. We have the, let's see, we have some routes, but not the ones that we need. Let's look at the unicast all. And let's say unicast all 10, 10, 10, 10 /32. It says we have the route target. Let's try clearing the routing table. Clear IP route VRF-A star. Show IP route VRFA. Okay, now the route got installed. So as I mentioned before, sometimes when you do the import and export policy, the redistribution gets hung. If before you go troubleshooting something else major, just do a clear IP route, VRF, the name, and then star, and see if that refreshes the redistribution. So in this case, it wasn't a config problem, just for some reason it wasn't actually converged. Okay, so now we have 777 and 10.10.10. If we look at this from 7's point of view, we should now ideally have the ISIS routes, which we do, and let's say from 10 as well. Show IP route ISIS. Okay, next let's do a ping to 7777 and source this from 10.10.10.10. So I have the route installed there, and it says the route is reachable through both router 2 and router 1. But for some reason, the traffic is not actually going through. Let's take a look at this from 7's side. And 7, okay, 7 has the route. No, 7 doesn't have the route. What happened here? Now it has the route. Now it doesn't. Okay, so it looks like something is changing in the routing table. Oh, we got an ICMP unreachable as well. Okay, let's do a debug IP ICMP and then do this ping. Okay, let's try the same thing from the other side as well. Let's ping 10.10.10.10. Source is 7777. And let's say debug IP ICMP. ICMP time exceeded. What would ICMP time exceeded mean? Now, if we were doing a trace route, time exceeded would be normal, right? Because we're only incrementing the TTL1 on a hop-by-hop basis to figure out what are the hops in the middle. But if we're doing a regular ping and time exceeded, it probably means what? It means there's a loop in the network. So for some reason, the packet is looping around and the time to live is eventually expiring. Let's look at this from a, let's try a trace route and see what's going on. So let's say trace to 7777. And actually, I should undebug first. Undebug all. So that's not right, correct? Because look, we have router 2 as the first hop, and then we have router 2 as the third hop, and the fifth hop, definitely something is wrong.